When working with hierarchical data, there are some pros and cons of modeling the data as a parent-child hierarchy to consider. First, the pros. The parent-child hierarchy gives us the flexibility to add as many levels as we need simply by adding in another row into our relational source and associating it with a row that was previously a leaf level member. We can then perform a process update on the dimension and we're done. With a standard hierarchy, we need to plan in advance whether we're going to support 3 levels, 4 levels, and so on. And if we want to add another level, we need to modify the dimension design. We need to update the relational source by updating many existing rows, whether we're using a single dimension table or a snowflake set of tables. And then we need to do a full process of the dimension, which then requires us to do a full process of a cube. It's not a trivial design change. In particular, the parent-child hierarchy is an easy way to model an unbalanced, ragged hierarchy. That is, we can have an inconsistent number of levels from each top-level member. Another way to think about that is we can have leaf-level members at different distances from the top level. That kind of flexibility allows us to easily skip a level if necessary. The problem is, there's a price for this flexibility. For one, there's the potential for slower processing of the dimension. The physical structure on disk for storing the dimension is different than we have for a standard dimension, and could impact the time it takes to process. If you're scheduling processing overnight, that might not be a problem. A greater concern is the potential impact of slower queries. I say potential for both of these issues because a lot of factors determine what impacts processing and queries, not just one design technique. Often what works fine in a small cube becomes a big problem when the amount of data in a cube becomes large. Now, large is difficult to define, but with regard to a parent-child hierarchy, a large dimension that could start experiencing processing or querying problems begins approximately at the 10,000 member mark. The reason for slower queries is that analysis services cannot store aggregations for the levels between the top level and the leaf level. That means it has to do a lot of computation at query time to determine what value to display if it needs to show members at any level between the top and the bottom of any branch. However, if we set the isAggregate property to false, we get only the leaf level aggregations. And the last thing to consider is that we can have only one parent-child hierarchy per dimension. In some cases, an alternative design might help. I've included a link at the end of this presentation for a tool that naturalizes or flattens the parent-child hierarchy. You can design your dimension as a naturalized hierarchy yourself, or you can download a tool from Codeplex to convert an existing parent-child hierarchy. Now, it doesn't necessarily make sense to do this for the account dimension because unless we're in a very large corporation, we generally don't have thousands and thousands of accounts. But we could have over 10,000 members if we have an employee dimension, or a pharmaceutical dimension, a stock portfolio dimension, and so on. Here's an example of a portion of the AdventureWorks employee dimension after the naturalization process. I've simplified it and eliminated first names to fit most of the columns on the slide. The top-level member appears in all columns of the row pertaining to that top-level member, Sanchez in this case, which is level 2, the level just below the all member. The next 2 rows for Bradley and Welker report directly to Sanchez. So you see their names appear in all columns except the level 2 columns. The row for Jiang shows he reports to Welker, and the last row for Mitchell shows she reports to Jiang. This table structure can support one more level if we were to add an employee that reports to Linda Mitchell. We can set the hide member if property in the user-defined hierarchy of the dimension to disable the levels that repeat the same name all the way down to the leaf level, which is level 6 in this case. Now, there might be a query performance problem with this approach due to the ragged hierarchy, but it won't be as significant as the performance problem for a query on a parent-child hierarchy.